So first of all, before entering into the container, we should know the difference between what is virtual machine and what is the physical server, and why we are coming towards this container. Okay, that is very much, that understanding is very much important. If you say initial days, it is started as a physical server. After that, virtual server came. Virtual server is nothing but, see, physical server, like your laptop, correct? You have hardware. On top of that hardware, you installed your operating system. On top of operating system, you install multiple application. Like you can install WhatsApp application if you want, or if you want Microsoft application. So like that, many application, whatever application you want, you could install it and you can use it. Okay, that is what previously it is started. Like in on physical server, we can install our applications, correct? So after that, this virtual machines came. So virtual machine also, we have two types. On top of hardware, we could install operating system. On top of operating system, you can install hypervisor. In two types of hypervisor, we have type 1 and type 2. Okay, so this is one of the type, that on top of hardware operating system you are installing hypervisor. Another type, on top of hardware directly you can install hypervisor. On top of that hypervisor, you can create multiple virtual services. Okay, like you might seen many virtual service, virtual machines, correct? Not virtual service, actually virtual machines. Okay,
Yeah, correct. Right.
so that is VMware, that gave a lot of boost in IT sector. So due to these virtual machines, we deployed our many application on virtual services, and it act as a vital role till today. Virtual machine is working, even though if we are coming towards container. On top of this virtual machine only, we are installing the containers. We are deploying the containers. Okay, so the major difference between operating system, sorry, physical server and virtual machine is, in your physical server you can just deploy your application, but you cannot share any hardware here. But in virtual machine, due to this hypervisor concept, what you can do, you can share the hardware among all the virtual machines which you are creating. Okay, say for example, I have my own virtual environment, that is virtual box I have. Okay, Oracle virtual box, or you can install VMware as well. This is just an example. VMware, this hypervisor type is totally different. Okay, just one example I'm giving to you. Oracle VirtualBox Manager we have. This is free, open source only. You can install it. But we are not going to work here anything. Just to give, I'm giving example of virtual machines. Correct. So this is my VirtualBox Manager. Inside it, I have installed many machines, virtual machines. Correct. So Prometheus server, Linux, all these are just names. So I'm installing Linux operating system. On top of it, I install my own applications. I could work it on it. So same, this is the type. This is how your virtual machines will work. Okay. So in on top of hypervisor, you can create multiple virtual machines like that. What is the advantage? This will share the hardware among all your virtual machines. Say for example, my laptop, I have 16 GB memory. Out of 16 GB memory, if you see, uh, for this particular system, 2 GB memory I allocated, correct? And for this Grafana system, I allocated 1 GB memory. Same like Prometheus, I allocated 2 GB memory, correct? So what happened, whenever I start this server, when it is powered off, it will free up the memory. It will not utilize any memory from my laptop. But the moment when I start this, what happened? 2 GB memory will be occupied from my base RAM, correct? My laptop RAM. Same like if I create if I start this machine as well, then totally 3 GB. This one 1 GB and the Prometheus server 2 GB. Totally 3 GBs memory will be occupied. Rest of the GBs only it will be allocated. I can use for my laptop purpose. Normally any other application if I access, then I could use it. So what happening here? It is sharing the hardware. It is taking the hardware from my laptop. Same like here, it in hypervisor, it will share the hardware to all your virtual machines. So that is very good advantage. That is why people still we are using virtual machine. Physical machine very hard nowadays. You could see very hard. One or two physical machine you could see that, but around 8 years before, you have lot of physical servers. Okay, if you are working as a Linux administrator, you have seen many physical servers. If any physical servers goes down, it is very critical to bring up. Okay, what is the advantage of a virtual machine? If one virtual machine goes down or corrupted, what you can do immediately, you can create another virtual machine. And there, if you have worked on big organization, they have the mechanism to take a backup of OS disk as well as application disk. Okay, so root related disk will be related to root, var, temp, and temp is the temporary directory, but OPT, correct? So these things and all application, sorry, OS file system, those file system will be stored in the SDA, something called SDA, SDB, you disk you have, correct? SDA disk will be taking backup, and another side you have the SDB, SDC. Those are the application disk. Those will be taking. You can take the backup. Okay, if your complete virtual machine is corrupted, it is not coming up at all. Even though you try to troubleshoot your kernel panic everything, that is not work out. If it is completely destroyed, what you can do? You already have the application SDB, SDC. Those disk backup you already have, correct? So you could keep that backup, and you can create your virtual machine. You can create new virtual machine on top of after that SDB, SDC you could attach back, so that your application data will not lose. Okay, there also there we have some issues, because the data backup will happen night 12 o'clock happen every day, right? So for example, morning 9 a.m. if your machine is corrupted, then from 12 o'clock to morning 9 a.m. data will be lost. You could get till yesterday night 12 o'clock, because we have a backup till yesterday 12 o'clock. So you have to compromise those losses. Okay, but your application will get up and start working. It will take, this process will take around 1 to 4 hours. Okay, sometime if your data is very small, then easily you could take a backup and you could run it. If your data are in TV size, then it will take a lot of time to recover the restore the data. After that, you start your application, that will take a lot of time. So it will take 1 hour to 4 hours. This is what happened 5 6 hours before. Okay, 5 6 years before. Okay, after that, this containerization came. What is the difference between containerization and virtual machine now? So if you see, in virtual machine, hardware is the base. On top of it, you have hypervisor. On top of hypervisor, you could create multiple virtual machines. But in container, base will be hardware. On top of hardware, you have the operating system. On top of operating system, what you can do, you can install the container runtime, that is container engine. On top of container engine only, you can create a container. Okay, here what happened, um, in containerization, it will not share hardware, because already it will take hardware from directly operating system, whatever this for this operating system assigned hardware, correct? Those hardware will be, it will be there. So in container engine, what it will do, it will share the software. What is the software? Instead of telling software, we could see the kernel. It will share the kernel. I'll explain you. So this is what the official image, you will get it in the Google wherever you go. But actual thing is, this is what the actual thing. See, infrastructure means wherever you install your operating system, that is what the infrastructure, or we could say hardware. Say, for example, on top of your laptop, you install the operating system, correct? So, for your operating system, what is the infrastructure? Your laptop is the infrastructure. Your laptop is physical machine. Okay, like if I take here, okay, here if I install any operating system, then this is virtual machine concept. Okay, so this is what my operating system. Okay, that is why I have simply mentioned that infrastructure or hardware. So wherever it is allow you to create operating system, that is what called infrastructure. Simply you have to understand in that way. That infrastructure may be your physical server, that infrastructure may be your virtual server, or whatever it is. Okay, sometime what happen, cloud, you will get the, we are today we are going to see how we are going to install EC2 instance. On top of it, how can we install container, all those things. So most of the time, this will be from virtual machine either, or else it will be EC2 instance. Today's organization, 85% they are using cloud machines only. Okay, or else you can create your own VMware in your data center and you can utilize that VMware machines as well. But most of the peoples, most of the projects, most of the IT companies today, they are using cloud based machines. Okay, so that is why I have mentioned here infrastructure. Infrastructure is nothing but wherever it allowing you to install your operating system, that is what the infrastructure. So on top of infrastructure, we will install Linux operating system. On top of Linux operating system, if you install any application, that is called virtual machine concept. Okay, that is not containerization, that is a raw virtual machine concept. But same on the infrastructure, if you install operating on top of infrastructure, you installing Linux operating system. Both are same, layer 2 same. But in the layer 3, you just adding container engine. Instead of installing your app directly, you are installing container engine. On top of this container engine, you can install your containers, you can deploy your container. It is not install, actually we have to tell, we can deploy our containers. So these containers OS level or OS level sharing will be happen. So this container engine will taking care of OS level sharing. What is OS level sharing? Say for example, you are from Linux background, correct? You know that the Linux operating system ISO image will be 4 point something GB, sometimes 5 GB, 6 GB, something like that. But on an average, 4 GB DVD will be there, correct? ISO image will be there. From that ISO image only, you have to, what you will do, you will install your operating system, correct? So if you see here, I have here, this is my Linux operating system. If you go to the settings, okay, and storage, here you have the ISO image. This here you could add the ISO image. If I go and select this any one of the ISO image, that will be maybe 4 to 5 GB ISO image will be there. Correct. That image you have to attach in your hardware, in your DVD or wherever it is. After that, you have to install the Linux operating system. Correct. So after you install Linux operating system, what is the root directory slash, correct? That root should occupy 3 GB or 1 GB, something like some GB it will be occupied, correct? So why it is taking those much GB? Because you have to install the binaries and libraries. So your operating system completely working on binaries and libraries. What is binaries and libraries? It is very simple. Binaries and libraries will provide you the program, macro program. That is what, if you take Linux, no, Linus Torvald, he only written the program, he only started the program, he only started the operating system, correct? He created operating system. After that, many people done some enhancement, that is different case, but it is started by Linus Torvald. If you take Linux operating system, correct? So he only written those macro programming, which means if you type any command inside your operating system, okay, if you type any command inside your operating system, how your operating system should react. Say for example, if you are creating Linux operating system, after system come up, then you are just typing uptime. What is the command? Uptime you are typing. The moment when you are typing uptime command on shell, it will go and check what is the libraries. Based on that library, it will execute that library, and it will bring out, give you the output. Same, if you type uptime 1 or something like uptime whatever it is, you don't give uptime, or you just miss last one character, what will happen? It will say this command is not valid, or this command is not available, something it will give you a message, which means in that name there is no macro programming, or there is no binaries and libraries are available, correct? So here it will share the binaries and libraries among the operating, among the containers. But in virtual machine, what happen? It will share in infrastructure monitoring, you can create multiple machines, correct? Virtual machines. So it is sharing the hardware here, but in containers it is sharing the Linux kernel or OS kernel, not only Linux kernel. If you are on top of your infrastructure, if you want Windows related containers, if you want to create, then you have to install Windows operating system. On top of Windows operating system, you could install container engine. On top of container engine, you can deploy multiple containers which can work on Windows servers, which means This container have the minimum binaries and libraries. The common binaries and libraries will be taken from the base operating system. Okay. Say for example, for if you take a Linux operating system, network part is there, correct? Network related or kernel related, which all the containers should have it should be there. The basic or common for all the containers, for all the applications, whatever you are deploying, whatever you have the common libraries and binaries, those will be it will be take from Linux operating system. Whatever it is not common, whatever the libraries and binaries not common, only those will be installed inside the container. Many people will say that container don't have OS and all. Container also will have OS, but that OS have minimum libraries and binary files which help you to install, which help you to run your particular application. Say for example, if you have a DHCP server, if you want to install DHCP server, if you want to create a DHCP server in Linux operating system, then you have to install some DHCP packages. If you want to web server, then you have to install some web server packages, correct? Same like here, if you want to create any container for web server, then it don't want any DHCP or any unwanted packages and libraries, correct? If anything common OS level binaries and libraries, if it need, it don't want to keep it here. Instead, what you can do, it can take from base Linux operating system. So that is what we are telling here. Container engine share the host OS kernel and packages, correct? OS kernels and packages, the common, again I'm telling the word is common. So common binaries and library files will be shared between these containers, and each and every container also will have the base OS, and that base OS will have very minimum. Very minimum means if this Linux operating system want 4 GB means here it may take only 230 MB, 250 MB, max to max 1 GB is enough for them. Why? Whatever the binaries and library files are having inside your container operating system, that is very minimal. That will help you to run this application smoothly. Okay. Rest of the things, networking related or anything other common binaries and libraries files will be shared between. It will take from Linux operating system. This is what the actual happening. But if you go and search in the Google, you will get like these types of images. Again, you may get confused, but if you when you are seeing here, you can easily come to know, okay, what is happening, how these containerizations are working. Okay.